Okay, let's look at this question. Here the graph is, so let f be the continuous function defined on -1 and 8. -1 is here until 8. This is the graph of the fx, whose graph consists of two line segments. We have two line segments here, right? It's shown above. Let g and h be the function defined by g here and f is here. Right now, the a here, they ask you the function k is defined by fx times by gx. Find the k derivative of the k derivative when x equals 0. Okay, so when you do a, like this a here, okay, so you do k derivative of x. So that will be equals to what? Use this one here. We're going to use what? Product rule, right? When we do the product rule, you have what? F derivative of the x times by what? G of x, and then plus f of the x times by g derivative of the x. So that's the derivative of the k. And then you're making what? X equals to what? 0. So that will be, we can get what? You gotta put everything here. The x will be 0, right? So you're gonna have a k derivative of the 0 equals f derivative of the 0 times by g x. G here must be a 0, right? So here must be a 0 and a plus f0 and then g derivative when x equals 0. So that's when we need to find the k derivative when x equals 0. Now let's find f derivative of 0. X equals 0, that's here. Derivative of the function f will be the slope of tangent line here. So if you find this one here, from here go rise, 1, 2, this is 3, so rise is 2, round is 1, right? So from here, rise, that's a slope, rise over round, because straight line. So this one will be equals to rise is 2 over 1. G0, G is this one here. Simply plug in 0 in, so you can get a G0 equals what? Square root 0 squared minus 0 plus 3. That's simply equals square root 3. So this one equals to square root 3 and add by F0. F0, x equals 0 here, here. This is the point here, is 3. This is 3 here. So F0 is 3. And then times by G derivative when x equals 0, right? How do you find a g derivative? We rewrite the g, this is the g, we rewrite this like this. We write it right here, okay? So that will be g x will be equals to, I write it in exponent form. So you have x squared minus x plus 3, and this is a half power, right? So when you do derivative of this one, equals what? You put a half in front. Power rule, x squared minus x plus 3. And then this is minus 1, so you're going to have a negative a half. And then you time by derivative of this. That would be what? 2x minus 1. Now you make what? X equals 0. X equals 0, this is 1/2. This one just a 3. Negative a half. And then 0, this is a negative 1, like this, right? So you're going to have a negative 1 over 2. This part you can put it down as square root 3. So you can put it here. So this is a g0. This is called g derivative of the 0 right now. So I'm going to see here. I put 0 here, 0 here, no more. So that's why you have 3 negative half power here. And time, but this is 0, so you have -1 here. -1 times half, just negative half. This one can put it down. Next negative exponent, you can change the positive exponent by 3 half power at the bottom as a denominator. 3 to the half power is √3, okay? I'm going to use this one, put it here now. So that will be -1 over 2 square root 3. Now, so this one will be 2 √3. And this is 3 times the -1. This is minus here, okay? And then you have this one. So you go numerator times by √3, denominator times by √3, okay? So we time this one, so rationalize. So you have -3 √3 over, this is a 3 at the bottom, so 2 times by 3, right? And 3 cancel, so you're gonna have what, 2 √3 minus half of the √3, right? So this one's on cancel, it's a half of √3. So this is 2 over 3, so that will be about 3/2 of √3. So the step is this here. This one, you can divide, you can do like, change the same denominator, this over 1, you time by 2, time by 2. So this one will be 4 √3 over 2 minus 1 √3 over 2. So that would be equals to what, 3 √3 over 2. Yeah, this is the answer, right? So that's the way we find this one equals to k derivative of 0. Okay, so we finished the first one now. For a look at this first one, what we did was simply use what? Product rule of the function, because kx equals fx times by gx. Use the product rule and then plug in x equals 0 for each of the function here. And then when you do f derivative is 0, that's the time when x equals 0 from here. And since this is a straight line, fx is a straight line here. So you can just simply go by rise over round to find the slope. Slope means the derivative when x equals 0. Rise to here, rise to round 1. Got this one. G0, simply plug in here. That's no problem. And add by f0, x equals 0, f here is what, 3. And then g, derivative of 0, we do derivative first. Derivative, we just write the exponent form first. 1/2, -1/2 here. Chain rule, go this one, right? And then you plug in x equals 0, so you got this one. You got this one. And then you plug in back to here. And then you time this part, both numerator and denominator, rationalize and simplify to get this. All right? Now, we go to the B now here. When you go to the B, you can see that when you do the B right here, this is B, the function m is defined by this, right? Function m is defined by this. Find m prime 5, right? The function m is defined by this one, right? Find m prime. So what are we going to do this one? We go this way here. When you do derivative, right? Here, what do we need to do is we got to use what? Use this function. This is B now here. I put it here B, okay? B mx equals what? Equals fx over 2g of fx, right? So when you do derivative, you gotta use what? Product rule, okay? No, quotient rule. When you do quotient rule here, this one, the half is the constant. This is the half. This part is the constant. You put it outside, okay? So you simply do derivative of this now. Quotient rule said derivative of the x, the top part times by the bottom, and the minus derivative of the bottom one and times by the top one, and then divided by the bottom one squared, right? So that's the quotient rule. When you have this, simply plug in, because they ask you x must be equal to what? 5. Here, this x equals to 5. So we look at the 5 here. This is 5 here. For fx, derivative of the 5 means from here. This is also a straight line. We've got to find the slope. We pick up the corner point. This is the corner point, and this is the corner point, okay? So we go down by 2, rise is -2, and the round is 3. So that means what? It's 1/2 here. So the derivative of the fx when x equals to 5, that's the time equals to what? -2/3, right? And the gx5. G5 is here, which is plugging 5 in, right? This is the 5 squared, minus 5 plus 3. So this is 25. 25 minus 5 is 20. So this is 20, but 20 plus 3 is 23. So this part is root 23. And the minus derivative of this now. Okay, we just did the derivative of gx, but we do it one more time, okay? Gx, so we have like this one, gx. I write it in the exponent form first. Square root of minus x plus 3, right? Is half power. So now we do g derivative of the x equals what? 1/2 x squared minus x plus 3 -1/2 power times by 2x minus 1, general. And then we're going to plug in what? We plug in the x equals what? 5, right? So I will get 1/2. This is a 5 squared minus 5 plus 3, -1/2. And then 2 times 5 minus 1, like this. Now we're going to do the calculation. 1/2. This is a 25 minus 5 is 20, is 23. 23, -1/2 power. And then times by this one, times this one will be 10 minus 1 is 9. So write it a nice way will be 9/2 square root 23. Now we're going to put this answer here, okay? And that's g prime of x when x equals 5. So you have a 9/2 square root 23, and times by f5. f5, this is 5. You go up here, you're going to hit on here. This is 5. So this is 5, right? Fx equals 5. Go up. Go to here, this is 5. So, and then we divide it by gx, g5 squared. G5 squared is 23, right? Now the rest of the work, we just simplify. So this is m derivative of 5, right? So we go half, so we just put like this one first. This is a 1/2, and this 1/3, so 1/23 like this, okay? And then we have this inside here. This one we can put as -2/3 root 23 here, and this one now. This part, we have to minus 45 over 2 root 23, right? Just a little bit tedious calculations, okay? Square root 23, like this, right? Okay, now this part you can do what? Rationalize, right? You time by root 3 here, you time by root 3 here, okay? So this part will be here. 1 times 1 is 1. This one times this one is 46. Leave it there, right? And then right now, inside here, this is a negative 2 root 3 over 3 minus 45 root 3 over, oh, this is 23, not just 3, my bad here. So you got time by here must be, this one must be time by root 23, time by root 23. So this one times this one, this is 23, time by this one is 46, right? This is 46, and this one is 45 root 23. Now, after you got this one here, you can get continue. 1 over 46, and then this one now here, we just leave like that. It's okay, I think, because this is 46 right now. This one. So if you want change to the greatest common factor, is fine. No, if you want change to the LCD, so you're gonna do it either this way here, this one time by 46, time by 46, right? So this one time by 3, you time by 3 here. That's fine, right? So you have 1 over 46, and then inside here, you're gonna have what? Let me get a calculator here. So you're gonna have 2 times by 46. Okay, you have 2 times by 46 equals to negative. So here is a negative 92 square root 3 over the bottom one is a 3 times by 46. You will get what? 138. And the minus this one now. You have 3 times this one is 12 root 23. Oh, this is root 23. Wait a minute, this is 23. 23, okay? So this is 23 here. So this one and minus 12. No, not 12. So here is 3 times 45. 3 times by 45. You got what? 135. 135 root 23 over 46 times by 3, got a 138. Same denominator right now, right? You got it? And then you see here, what I did was like this, just simplify. It's not big issue. I put this one here. I put this one together. You will get what? This one, 1 over 46, right? And then this part here is a negative 2 root 23 over 3. And then this part here, I change 5 times 9 is 45. I time by root 23, time by root 23 for both numerator and denominator. I got the bottom one is 46 right now. And then the numerator is 45 times by root 23. And then time by 3, change the common denominator, time by 45, time by 45, change the common denominator, right? And then when I got that one, 3 times by 43 will be what? The 138. And the top part is negative 92 root 23. And the minus 3 times by 45 is 135, root 23, this bottom is 138. Okay, that's good. So now you go 1 over 46, right? Times by the inside here. Inside here is this. You have a negative 92 of root 23 minus the 135 of root 23. So you simply add the two numbers, root 92 added by 135, you got what? 227. So you have a negative 227 root 23 over 138, right? Now, let's do the calculation of this part to see if we can, this times, so if we can get this part and this part simplified, okay? We do like this, negative leave aside. So the answer will be negative here, okay? And then you do 227 divided by parenthesis 46 times by 138 closing parenthesis. You get what? The decimal, and you see the fraction. What's that? Oh, they just timed them. You cannot simplify further. So that means what? You got 227 over 6348 and times by root 23. So that will be the function is defined by this equals to, this one will be equals to what? M5, okay? Now, let's go to next one here is find the value of x for this to make sure that f derivative of x equals hx. So we're using the graph of the f and the work on the h, which is the derivative first, right? Okay, so let's do this one, okay? So when we do this one, because nothing with business with the g right now, so I may erase this part first. I may erase this unnecessary part. The g's, we don't need to use the g for this question anymore. So we use this space to do this now. I leave the left side here in case we need some information result from what we did. We can quickly take it, okay? Now, here, the A set should be from -1 to 2. So -1 is here, 2 is here. That's this part about the graph of fx, right? So they ask you to find f derivative. So when you have f derivative, let's lower down a little bit with the graph here, okay? F derivative from -1 to 2, that's a straight line here, right? That's just a straight line. So that means if you do f derivative, if you do here, if you do f derivative of x, but x should be in between -1 and 2, that's a time just slope of what? This line, right? Rise 2, round 1. That's equals what? 2 over 1. Constant, right? That's a derivative. Because we limited x in between -1 to 2. But if you go to this side, that's different. But right now they ask you the value of x limited with this. So this is the one, x is what? Bigger than -1 and then less than 2, like this. This is the condition. How about hx derivative? Hx is derivative from here. So hx derivative equals to 5ex So EX derivative is still EX. 5 is constant, leave it here. And then minus the 9. And the sine derivative equals what? Cosine X, right? Get it? So, and we want this one equals this one. So that means that this one equals what? 2, right? Now, this kind of function, you cannot solve it by hand. So what I'm going to do is, I make this 2 equal, right? We got this equation. And then we can move this on this side, minus 2 on both sides, okay? So we will get 5EX minus 9 cosine X and what? Minus 2 equals 0, right? Okay, so we got this equation right now, right? When we got this equation, we need to solve this equation now, right? We use the calculator, okay? But before we do that, here, my understanding here is this, the angle should be in radian, okay? We'll leave it as a radian. So make sure you check with the mode of your function. Here is under the radian first, under the radian, okay? Like this. And then you're gonna go by, you key in this function. So you're gonna have what, 5 e to the x power and the minus 9 cosine x and the minus 2. Okay. So 5ex minus 9 cosine x and minus 2. So that's the function I keyed in, okay? After that, you go second function, calculate, you find the zeros. And so when you do this one, you gotta be careful with what? You make sure your window is match, okay? So what you're gonna do is this, you adjust the window, because they told you that this one, the x is just in between -1 and 2, right? So we can make the window as, we put as a negative, the regular one, okay, -10, +10, and go increase by 1 and -10, +10, and increasing by 1, scale increasing by 1, okay? So you go second function, calculate, and 0. You can get what? You can see the graph there. Okay, here, this is the graph. But this graph, since we just look for what? X in between -1 and 2. So probably we're gonna check on the 2 intersection on the right here, on the right part, okay? Close to the interval -1, 2. So we go by, move the cursor to the left, and then left bound, and then check on the right bound and the gas. So they gave us 1, 0 is at -1.6, but definitely this is not good. You know why? Because they ask you the x should be what? In between -1. So we're going to go the other one now, okay? Second function, calculate, we'll put a 0, and then we move the cursor to the left bound, okay? And then we go to the right bound, enter, guess. Okay, we found another one, which is 0.6 some. So that would be a good one, okay? So from there, we can find out x equals what? 0.622. because on this AP Calculus College Board, they require you got what, 3 decimal places. So we just finish up here. So by that way here, find the value of the x for this interval such that this will equal. So the method is just simply like this. We make this derivative. The fx derivative will be just 2, because this is from here in between -1 and 2. So rise to 2, rounds to 1. We got that already. And then when you do the hx derivative, we do derivative. This is a 5, right? We're using this function, right? So this is a 5. Ex derivative is still ex. Minus 9. Constant leave there. And sine derivative equals cosine x. And to make this one equals to 2, right? Because this 2 equal, huh? And then move this on this side, you got this equation now here. And then use the calculator, okay? So you can solve this answer. All right? So that's all for this question. If you have any questions, please let me know. Thank you. Bye-bye.